We'll do certain questions today, as well as we'll continue the same in our next class also. We are going to do lots of questions based on this as well as previous year questions. Chalo, we start with the first question. Now these are all based on the formulas. I hope you are learning the formulas. Make your own notes, create the formulas, create a formula book where you're writing all the formulas, right? All the formulas, like we have done sum rule, product rule, multiple angles, sub multiple angles, and then what else? Allied angles, all these things we have covered. So go through the formulas every day, because in case if you just miss out the formula, and definitely these formulas have applications in all over calculus as well. Not only in trigonometry, you have this in calculus. Anywhere, in fact, anywhere in any chapter you can get the application. So go through them every day. Okay. So first of all, we are going to see certain patterns of questions, which has been basic patterns of questions, which is asked in the exam, and then we are going to move on to difficult questions. Chalo, try out this one. 3 tan theta into tan phi is equals to 1. This is given, and you have to prove that 2 cos theta plus phi is equals to cos theta minus phi. You have to prove this. Okay. Definitely in this case your formula is applicable. Just basic knowledge of formula will work for this question. Basic knowledge of formula. I hope all of you has been just simply revising the formulas, because these are very, very important. So first of all, you have 3 tan theta into tan phi, which is 1. You have to prove that 2 cos theta plus phi is equals to cos theta minus phi. So what we'll do is, first of all, from here in this particular identity, so we have 2 cos theta plus phi, and on the right hand side you have cos theta minus phi. What we can do from here is we can write this as, in fact we can write this as cos theta plus phi upon cos theta minus phi, which is equals to 1 by 2. You can write this thing, cos theta plus phi upon cos theta minus phi is equals to half. So you know this value of this thing, and now you can expand this. Now without even just writing this or representing in this format, you can write this. But since you have tan theta and tan phi over here, in fact we can also break this tan theta and tan phi. You know, we have 3 tan theta and tan phi over here is equals to 1. So we can just simply break this as sine theta. Sine theta will be there and sine phi will be there upon cos theta and cos phi will be there. On the right hand side, we just simply bring this as 1 by 3. Okay, because all the things on the left hand side you can see that we have in terms of cos, and after we just simply break this into the formula of cos a plus b and cos a minus b, this will still be remain in the terms of sine and cos. So it is better to bring this into the format of sine and cos. Now what we do is we break this into the formula of cos a plus b and cos a minus b. Cos a plus b is cos a cos b minus sine a sine b. So what we do is, this is basically cos theta into cos phi minus sine theta into sine phi divided by, similarly, cos theta minus 5 cos a minus b is basically cos a cos b plus sine a sine b. So basically we will have cos theta into cos phi plus cos theta sine theta into sine phi. Okay, right. So what we have to do is we have to basically prove this identity, which is equivalent to this thing. Okay, which is equivalent to this thing, and we are just simply simplifying from the here, right? Definitely we are simplifying, as you are saying that we have to apply componendo and dividendo. Why we will apply componendo and dividendo? This is what you're going to see now. what we are going to do from here is, from this particular part, sine theta into sine phi divided by cos theta into cos phi. Okay, from this particular portion I am saying sine theta into sine phi divided by cos theta into cos phi. What we'll do is we are going to apply componendo and dividendo. If you remember what is componendo and dividendo, you have learned in your junior classes what is componendo and dividendo. It is used to simplify. It's a method of simplification actually, and how we will simplify, we are going to add in the numerator plus denominator, and in the denominator we are going to create numerator minus denominator, so that we can just approach this particular value to some extent I'm saying. Because if you just see from here, if you apply componendo and dividendo, so numerator plus denominator will come in the numerator. Okay, so this is your numerator. In the numerator now you will have numerator plus denominator. So sine theta into sine phi plus cos theta into cos phi upon sine theta sine phi minus denominator, which is cos theta cos phi. And this is equals to, since you are applying componendo and dividendo, you have to apply on both the sides. 1 plus 3, same here, 1 plus 3 divided by 1 minus 3. So what we have in this case, cos theta cos phi, and we have sin phi sin theta in the numerator. So what we will have? So we will have sin theta into sin phi. And if you take a negative sign, minus sign jodi ekta common niye, if you just take a minus sign common, then you will get back the answer. So what you will do is, you just simply take a minus sign common and then simply reverse this from here itself, from this particular step. Take a minus sign common, reverse this, you will get back this identity. Kore dekho, just simply take minus sign common, reverse this. So sin theta sin phi minus sign common ashbe, so cos theta minus cos theta cos phi minus sin theta sin phi divided by, yeah, ache cos theta cos phi plus a ashbe, ar sekhane 1 plus 3 thakse 1 plus 3 or upon 1 minus 3, to ekta minus minus cancel hoye jabe, 1 by 2 thakbe puro, same thing. And we are basically proving from this particular identity, 3 tan theta into tan phi. So based on these concepts, actually, we have a lot of questions which are helpful now. Nowadays, we are getting these type of questions, very common type of question. Let me do one question from your 10+2 book only. 10+2 book, this is an objective type question, you will find this. You have to find what is tan 2 alpha. This is a very nice question. In fact, it is from your 10+2, most probably. This is a very nice question where you have multiple concepts involved. Cos alpha plus beta is given to be 4 upon 5 and sin alpha minus beta is given to be 5 upon 13. You have to find what is tan alpha. Alpha beta both lies from 0 and pi by 4. Ultimately, you are finding tan 2 alpha, but also you have alpha and beta as well in our given information. Both alpha and beta lies in between 0 and pi by 4. So tan 2 alpha you have to find. So basically in these type of questions, you have to find the pattern in which we are going to proceed first. So to find the pattern, actually, to basically you need to have a good observation power of the angles. Every time I say observe the angles to find a common pattern or some beauty with the angles. Either adjust them or do something so that we can easily solve the question. In this case, one pattern over here is, you see, if you just carefully see, you have tan 2 alpha and we have alpha plus beta over here. So what we are going to do is, we are going to write this alpha, 2 alpha. We are going to break this, adjust this angle of this tan theta's part I am saying in terms of alpha and beta. Now 2 alpha, so definitely we can write this in alpha plus alpha. So to bring one extra plus beta and minus beta, we'll simply add and subtract. Basically what I'm trying to say is you can write this 2 alpha as alpha plus alpha. Further, we can just write this as alpha plus beta minus, or let's say alpha plus beta plus alpha minus beta. Plus beta minus beta cancel outs. Ultimately, so tan 2 alpha can be written as tan alpha plus beta plus alpha minus beta. Okay, simply we are adjusting. So we are adjusting this to tan 2 alpha as tan alpha plus beta plus alpha minus beta. So in this case, you have certain more concepts involved. You have to focus, because now you all will say that we can gradually just simply find out this particular values of alpha plus beta. So we have tan 2 alpha and tan alpha plus beta plus alpha minus beta. So now you all will say that we know the value of cos alpha plus beta. We know the value of sine alpha minus beta. So gradually by the triangle rule, you know what is theta. You can generally find out tan alpha plus beta and tan alpha minus beta. Because you will say that we can simply expand this thing tan alpha plus beta plus alpha minus beta. You can treat this as A and treat this as B. So you can break this into tan A plus B. That is basically tan alpha plus beta plus tan alpha minus beta upon 1 minus tan alpha plus beta into tan alpha minus beta. So this is what you have ultimately, first of all. You need the value of alpha plus beta, means tan alpha plus beta and tan alpha minus beta. So here you have to take care of two things. Mainly the angles. Actually in this case it's mentioned that alpha beta lies between 0 and pi by 4. Alpha plus beta and alpha minus beta, although you know what is theta in this case, you know what is cos theta, sine alpha minus beta. I am treating theta in this case as alpha plus beta and alpha minus beta. So the thing is, you can find out tan alpha plus beta and tan alpha minus beta using the triangle rule, because you know what is this, cos alpha plus beta is given to me 4 upon 5, right? And you know that this is basically what, cos theta is 4 upon 5 means what, base by hypotenuse is given, right? But before that, whatever tan you are finding, in this case one problem is that angles are mentioned, alpha and beta is mentioned to be 0 and pi by 4, right? 0 and pi by 4 is mentioned. So gradually in this case, you have to check that where this alpha plus beta and alpha minus beta is lying. Be very careful with this. You have to check that where this alpha plus beta and alpha minus beta is lying. You need to check the sign of tan theta. Actually tan theta jeta ashbe, to tar to just sign jeta, what is the sign of that, you have to be very careful with that, because angles are mentioned in this case where alpha and beta lies. What I'm trying to say is, you know that both the angles are lying in between 0 and pi by 4. So tan alpha plus beta, first of all, if alpha lies between 0 and pi by 4, so definitely alpha plus beta will lie between 0 and pi by 2. Minimum it will be 0, maximum this will be pi by 2, right? And this is a first quadrant angle, 0 to pi by 2. This is a first quadrant angle where tan is positive. Everything is positive. All the 6 trigonometric functions are positive. This is a first quadrant angle. So tan is positive in this case. So there is no issue with this, right? You need not worry about the sign of this. Now, if suppose this would have been some different angles, like different quadrants, so definitely accordingly you have to take the sign of that particular tan. Like tan, it could have been tan something negative as well. right? So basically in this case, since it's a first quadrant angle, so definitely it's a simply a positive. So tan in this case is positive. So you can just simply gradually find out cos alpha plus beta is 4 upon 5. Now this is basically what? This is base by hypotenuse. So base is 4. You can consider base is 4 and hypotenuse is basically your 5 in this case, right? So therefore you can simply find out what is tan alpha plus beta from here. Simply check by the triangle rule. It is what? It is basically tan alpha plus beta from here will be 3 by 4. Right? Perpendicular by base. Okay. Similarly, same thing goes for now. You know the value of this thing tan alpha plus beta, which is 3 by 4. This is now basically 3 by 4. But what about this thing tan alpha minus beta? What is tan alpha minus beta? You need to know the value of this thing. If you see alpha and beta both lies between 0 and pi by 2, you cannot say that alpha minus beta. If you just simply do this alpha minus beta, 0 minus 0, pi by 4 minus pi by 4, this becomes 0. This lies between 0 and 0. That is not a valid argument, right? You cannot say like this. But in this case, sine whatever is alpha minus beta, this tan alpha minus beta, definitely you can understand that you'll get the value from here. Now in this case, you will face a concept which you will learn right now, and just you're learning this for the first time. I don't know if you're learning this for the first time, but I think we have done these concepts before in calculus as well, in functions most probably. The first of all, in this case, for the values of for a particular values of alpha minus beta, actually you have to find the possible range of values of alpha minus beta. Where does alpha minus beta lies? First of all, alpha minus beta, to find out the value of alpha minus beta, you have to find the minimum value and the maximum value. That is what we are finding, minimum value, maximum value. But in this case, how you will find is the minimum value, this particular part. To get the minimum value of alpha minus beta, what you have to do is you have to make certain changes or make certain adjustments in this alpha minus beta. What I'm trying to say is alpha minus beta is minimum when alpha minus beta is minimum when this particular alpha is very small and this particular beta is very large. When beta is higher, like beta is more than alpha, then you will get the minimum value. When beta is more than alpha, you will get the minimum value. And when alpha is more than beta, you will get the maximum value. Right? What I'm trying to say is minimum value, to obtain the minimum value of alpha minus beta, when alpha is small and beta is bigger, then you will obtain the minimum value. Right? The small means small in the sense I am saying it becomes 0. If alpha is 0, beta is bigger. Beta is what? In this case, max to max you have pi by 4. So when beta is maximum, beta is pi by 4, alpha is 0, you will get back the minimum value. So if you put this as 0 and you take the value of this as pi by 4, so 0 minus pi by 4 is basically minus pi by 4. This is the minimum value we find in this case of subtraction. And what we'll do in this case is, for the maximum value of this particular thing, alpha minus beta, when alpha is bigger, beta is smaller, when alpha is the maximum value and beta takes the minimum value, then you will ultimately get the maximum value of alpha minus beta. When this is 0, and alpha is basically now pi by 4. If I take the value of this as pi by 4, whatever is the maximum value, I'm taking this as pi by 4, beta becomes 0, then you will get the maximum value. So the maximum value is now pi by 4. Write this down somewhere. Minimum value of alpha minus beta is obtained by reducing the value of alpha, increasing the value of beta. When alpha is minimum, beta is maximum, we get the minimum value. When alpha is maximum, beta is minimum, we get the maximum value. This is a basic concept we have just developed. Now in this case, first of all, we have got the value of alpha minus beta, which lies in between minus pi by 4 and pi by 4. This is what you're getting. Minus pi by 4 and pi by 4, and not from 0 to 0. Don't do this thing. Alpha minus beta, you are having 0 to pi by 4, 0 to pi by 4. So what you're getting is 0 minus 0 and pi by 4 minus pi by 4. No, definitely no. That is a complete blunder mistake. Value of this is 0. No. Now in this case, there is one more correction we are going to do. What is that correction? Method of correction. We have done this in range most probably. We are going to do one correction in this case. This range is not a perfect range. Now this is there is some mistake in this, so definitely we are going to correct this range. It is from minus pi by 4 to pi by 4, right? Minus pi by 4 to pi by 4 is there. But in this case, if you see, minus pi by 4 to pi by 4 is fine, but the problem is sine alpha minus beta. If you see sine alpha minus beta, this thing is positive. It is given to be positive. Sine of theta's part, this thing is positive. This is given to be positive. So in this case, if this is positive, so alpha minus beta, this theta's part actually cannot lie in between minus pi by 4 and pi by 4. This theta's part actually cannot lie in between minus pi by 4 and pi by 4. Okay. Because this particular sine's part, sine theta's part is positive. So what we have is, so in this case, what is the correction? The correction should be minimum value would be from 0 to pi by 4. This is the correction we are simply creating. It will be from 0 to pi by 4 and not from minus pi by 4 to pi by 4. Concept of method of correction we are doing. So what we have, once again I'm repeating, sines theta's part is positive in this case. It cannot, the angle actually alpha minus beta cannot lie in between minus pi by 4 and pi by 4. Minimum this should have been 0. Minimum this should be 0 and not minus pi by 4. So we have from 0 to pi by 4. So alpha minus beta, this theta's part actually lies in between 0 and pi by 4. Now there is no problem. Now this is your angle. This is the range of values of alpha minus beta. Alpha minus beta lies in between 0 and pi by 4. Okay. And 0 and pi by 4 means definitely this is what? Tan theta will be what? Positive only. 0 and 45 degrees, this is what? It is positive only. Tan theta's part will be positive only, so no problem with this. Now you can gradually sine tan's part will also be positive. Now simply find out what is tan alpha minus beta. Sine alpha minus beta is given to be 5 by 13. So tan alpha minus beta will be what? 5 by this will be what? 5 by 12. Right? Same triangle law. So tan alpha minus beta will be 5 by 12. Okay. So this particular value of tan alpha minus beta is 5 by 12. Okay. There are lots of questions. I'm going to solve one by one. Chalo, next question. All of you try out this first. Same logic is used to solve this question. Tan theta is given to be root A by root B. A, B are positive real numbers. Theta belongs to the first quadrant mentioned. You have to find the value of sine theta sec to the power 7 theta plus cos theta into cosec to the power 7 theta. Okay. The logic which is used in this question is the same. Comparatively much more easier than the previous question. Let's simplify this. This is quite simple. You have tan theta is basically root A by root B. You consider like this. This is tan theta is basically root A upon root B. And AB are positive real numbers and theta is in the first quadrant. Okay, yes. Theta belongs to the first quadrant. This is one benefit you have. Theta belongs to the first quadrant. You have to find the value of this thing. Very simple. Simply see what is tan theta. Tan theta is what? Perpendicular by base. You know perpendicular, you know base. Simplify this expression. You have sine theta into sec to the power 7 theta. Right? So we have sine theta into sec to the power 7 theta. We can write this as 1 upon cos to the power 7 theta divided by cos to the power 7 theta. Similarly, we have cos theta upon cosec to the power 7 theta. Write this as sine to the power 7 theta. Now, if you further simplify this, we have sine to the power 8 theta plus cos to the power 8 theta upon cos to the power 7 theta into sine to the power 7 theta. This is what we have. Now simply see what is by the triangle rule. You have perpendicular by base. Perpendicular is root A, base is root B. Root B, root A. Right? What is this thing? Root A plus B. Right? This is root A plus B. So simply put these things, all these things you have sine, you can find out what is sine, this thing, sine to the power 8 is what? Sine theta whole to the power 8. So simply find out what is sine theta and simply put the value. So what is sine theta? Sine theta is basically root A by root over of A plus B whole to the power 8 plus cos theta. This thing is cos to the power 8 theta. So we have root B upon root A plus B upon root over of A plus B whole to the power 8 upon this thing which is upon we have cos to the power 7 theta into sine to the power 7 theta. So what you do is in this case you simply take this entire cos theta and just simply write this as cos theta into sine theta whole to the power 7. Right? So we have this thing as in the denominator we have cos theta into sine theta, that is basically root A upon root A plus B into root B upon root over of A plus B whole to the power 7. Now simply just simplify this, you will get A as the answer. You just need to simply simplify this, that's all. Let's do some more different types of questions. Different types are there. We are going to cover all of them one by one. You know, by this time you should know what are the multiple formula, sub-multiple angles, multiple angle formula, compound angle. All these things should be clear by now. Acha, you have to prove that tan 71 degrees into tan 64 degrees is equals to 1 plus tan 71 degrees plus tan 64 degrees. Okay. Now regarding these questions, these type of questions I am saying, where you have tan and certain identity is there, you are asked to prove these things. Tan 71 into tan 64, you have to prove this thing. Prove this. Regarding these type of questions, what you are going to do is you are going to see the same thing. Observe the angles. Every type of questions I'm saying, observe the angles, see how the angles are behaving or what is the nature of the angles, if there is any common similarity between the angles, right? So what we do in this case, one similarity in this case, you can find that in this case we have 71 as well, 64 as well on the left hand side, and we have 71 and 64 on the right hand side, right? So in this case, one thing we can get, that is basically 71 plus 64. Try to find out the pattern. That is the most important thing in these type of questions. Find the pattern. 71 plus 64 is how much? This is 135, right? 71 plus 64 is what? 135. And 135 is a standard angle. You can take any value like tan 135. If you take tan on both sides, you will easily get this. What is tan 135? Tan 135 is basically what? 180 minus 45. Tan 135 is a common angle. You can find out this 180 minus 45. That is basically tan pi minus 45. Tan pi minus 45 is minus tan 45, which is minus 1. So what now? Next, you can just simply take tan on both sides. So we have tan 71 plus 64. And this is tan 135. Tan 135 is minus 1. And this thing on the left hand side, you can just simply break this thing. What is this? This is basically tan A plus B. And this is tan A plus tan B upon 1 minus tan A into tan B. And this is equals to tan 135. Tan 135 is basically minus 1. You can think like this. Tan 135 is basically 180 minus 45 degrees. That is basically pi minus theta. What is tan pi minus theta? Pi minus theta means this is your from here to there. So we have 0 to pi. This is pi, and pi minus theta will be over here in the second quadrant. The second quadrant, you have tan is negative. So we have minus of tan this thing. So this is basically minus 1. Now on the right hand side, you have minus 1. You have asked to prove this identity. How will you prove this? We have tan 71 plus tan 64. Now cross multiply, that's all. So this becomes what? Tan 71 into tan 64. And here you have minus 1. So what is this? Now you're just going to simplify this. This is what? Tan 71 into tan 64 is equals to 1 plus tan 71 plus tan 64. That's what we are asked to prove, this thing. So this is one type of question where you have to observe the angles and you will find that certain similarities are there. Every time you have seen that in these type of questions of identities of provings and all, we have done in the previous classes as well, we have done that short trick where there also we are observing the angles. Angle observation is very, very important in this case, where you have these type of identities. You can get these type of identities in integration as well. Integration function will be given. You are asked to integrate certain functions where you have these identities. There you have to simplify the function, or else you cannot directly integrate that. Unlike differentiation, you have rules to differentiate. We don't have general rules to integrate in general. Okay. Let's do one similar problem of this type. Okay, so we have this question now. You have to prove that tan 70 is basically 2 tan 50 plus tan 20. So once again, you can see the beauty of the angles now. Observe the beauty of the angles. You have 70 degrees. Right hand side, you have 50 and 20. Obviously, one thing which will come to your mind first, this is basically you will start with what? You will start with 70. 70 is what? 50 plus 20. Let us start by that approach. We have 70 degrees. 70 is nothing but 50 plus 20. So once again, observe the beauty of this particular angles. 70 degrees, 50 plus 20. Now simply take tan on both sides. Simply take tan on both sides. If you take tan on both sides, so we have tan 70 degrees. We have tan 70, which is tan 50 plus 20 degrees. Tan 50 plus 20 degrees. Now what you're going to do is expand this tan 50 plus 20. That's all. Expand this thing. So this is what? This is tan A plus B, tan 50 plus tan 20 upon 1 minus tan 50 into tan 20. Right? So tan 50 plus tan 20 divided by 1 minus tan 50 into tan 20. Okay. Now what you're going to do is, now you're going to simply simplify, that's all. If you cross multiply, we have tan 70 minus tan 20, tan 50 into tan 70. It looks better. 20, 50, 70 like this is equals to tan 50 plus tan 20. On the right hand side, we are simply cross multiplying, that's all. So you have to ultimately prove this identity. You are getting this big identity. How will you simplify this? Once again, angle observation, nothing else. What will I do in this case is tan 20 and tan 70, which you are seeing in this case, tan 20 and tan 70. What is tan 70? We can write this as what? Tan 70 is what? Can we write this 70 as tan 90 minus 20? We can write this as tan 90 minus 20. Or you will say that can we write this as tan 20 as tan 90 minus 70? That is also fine, same thing. But ultimately, we are writing this in the format of 90 minus theta, pi by 2 minus theta. Tan 90 minus theta is what? Cot theta. Right? Tan 90 minus theta is what? Cot theta. This is cot 20. Cot 20. And here you have tan 20, here you have cot 20. Cot 20 means what? 1 upon tan 20. So this sin 70, actually I'm saying that this sin 70 is the same as 1 upon tan 20. So tan 20 and tan 20 gets cancelled. Ultimately you are left with tan 70 minus tan 50. On the right hand side you have tan 50 plus tan 20. Right? So I'll do it over here itself. On the left hand side we have tan 70 minus tan 20 has been cancelled. Now you're left with tan 50. And on the right hand side we have tan 50 plus tan 20. So just simply take this tan 50 on the right hand side, that's all. You'll get tan 70 as 2 tan 50 plus tan 20. That's all. Hence proof. That's all we have asked to prove. Clear with this? Very basic question. Observe the angles. Every time I'm saying, whenever you see these type of identities, there might be some common thing with the angles which you can just create, or certain adjustments which you can create with the angles. This is what you have to notice. Right? Let's do one more type of question, another type of question. And now based on that particular type, there was one question on like from ISI 2012. We are going to solve that as well. But first of all, let's start with the type. Let's see some basic question. Basic question. Now this thing, basic one also, it's from your 10+2 book, but it's still a very basic question. It's from your 10+2. The question is from your 10+2, but this is another type of question. Let us see that. Okay, so we have A plus B plus C. A plus B plus C is what? This is the angle of the triangles only. That's all. Sum of the angles of the triangle is 180 degrees pi. That is what is given. You have to prove that tan A plus tan A into tan B into tan C is tan A plus tan B plus tan C. That is what you need to prove. Right? How to proceed from here? First of all, you have done both the formulas of tan of two angles, so the sum of two angles, A plus B, tan A plus B. I think you have done the formula of tan A plus B plus C as well. What you can do is, in this case, best way, definitely you can see that certain tan terms are there. So what we are going to do is, we are going to first simplify this thing and take tan on both sides. So you can write this A plus B as pi minus C and then take tan on both sides. We can take tan on both sides. So we have tan A plus B is tan pi minus C. Now this one, you know, tan A plus B is nothing but tan A plus tan B divided by 1 minus tan A tan B. Formula: tan A plus tan B upon 1 minus tan A tan B. On the right hand side, we have tan pi minus C, tan pi minus theta. What is tan pi minus theta? Tan pi minus theta is minus tan theta. That is basically minus tan C. Right? Now just simply cross multiply, you will get the answer. That's all. Simply cross multiply. This becomes what? Tan A tan B into tan C minus tan C. Right? And simply take the tan C on the left hand side. What I'm trying to say is just simply cross multiply. That's all. So tan A plus tan B is basically tan A tan B tan C cross multiplication minus tan C, and simply take this tan C on the left hand side. So we have tan A plus tan B plus tan C. That is basically tan A tan B into tan C. That's all. Hence we have proved this. This is a very nice identity which you can just remember for your fast calculations as well. In fact, for your fast calculations, you can remember this identity, tan A tan B into tan C. I have seen questions involving this particular identity. You can mark this with a star. This is a very important. You need not memorize. Even if you don't memorize, you can just simply gradually generate this. Okay. So you all try on one similar question based on this particular type. Let's do one more question of this type. Prove this. Okay, chalo, let's discuss this. A plus B is given to be pi by 4. You have to prove that 1 plus tan A into 1 plus tan B is equals to 2. Same thing you have to bring in terms of tan. So it's better, it's given to be A plus B, which is pi by 4. Take tan on both sides, that's all. Your problems will be easily solved. This is what tan A plus B, tan A plus tan B. Same thing, tan A plus tan B upon 1 minus tan A tan B. Tan pi by 4, 1. Now cross multiply. Cross multiply, then factorize. Tan A plus tan B is basically 1 minus tan A tan B. Cross multiply and factorize. On the left hand side, we have so we have tan A tan B, and here we have 1 plus, what I'm going to write is 1 plus tan A, because you need to bring 1 plus tan A, so you need 1 plus tan A. So 1 plus tan A, and you have tan A tan B, so you just take 1 tan B extra. What I'm trying to say is, you write down this to be 1 plus tan A. Write down this as 1 plus tan A plus tan B plus tan A tan B. Okay, and since we are taking one extra 1 on the left hand side, so add 1 on the right hand side. This becomes 2. Adding and just simply adding 1 on both sides. To balance that, we are simply adding 1 on both sides. The right hand side becomes 2. Why we are doing this thing? We need one tan A, 1 plus tan A and 1 plus tan B, because you will see from this particular term you are getting 1 plus tan A. Factorization, basic factorization, 1 plus tan A we are getting. And from this particular term, just simply take out tan B. You will get 1 plus tan A, right? You take out a common tan B and you will get 1 plus tan A. So we have 1 plus tan B. On the right hand side, we have 2. Basic factorization, that's all. Hence, we have proved this. Now there comes the question of the ISI entrance, ISI 2012, based on this concept. This particular question had 2 parts actually, 2 subparts were there actually. This was the first question of ISI admission test 2012, that year, from which in fact your BStat and BMath used to come as just a single paper, a single question paper. Before 2012, the question paper would have been different. Like BStat and BMath used to be a separate exams. This is from ISI 2012. All of you try out first, then I'll help out. X, Y, Z be the angles of the triangle. You have to prove that tan x by 2 into tan y by 2 plus tan x by 2 into tan z by 2 plus tan z by 2 into tan y by 2 is equals to 1. This is from ISI 2012. Subjective question. First of all, x, y, z be the angles of the triangle means x plus y plus z is equals to pi. Instead of writing this information, giving this information, simply they have mentioned x, y, z be the angles of the triangle. Definitely some of the angles of the triangle is what 180 degrees. All of you know this thing, basic logic. Now you have x by 2 in the angles, so you have to carefully observe the angles of these tans. So what we have, tan x by 2, y by 2, x by 2, z by 2, like this. To convert this, pi means what? This is basically 180. So can we say that x by 2 plus y by 2 plus z by 2 is basically pi by 2? Dividing by 2, or you can say that we are simply taking this is what? This is basically a pi is basically 180. We are trying to represent this in terms of 90 because angles are in terms of x by 2, right? So we are dividing by 2. X by 2 plus y by 2 plus z by 2, which is pi by 2. This becomes pi by 2. Fine. Pi by 2 means 90, basically 90 degrees in terms of degrees. So we have x by 2 plus y by 2 is basically pi by 2 minus z by 2. Can we say this? Pi by 2 minus z by 2. Fine. See how we are approaching the question. Observe the how we are approaching this particular question. So what we have in this case, we have now we take tan on both sides. So we have x by 2 plus y by 2. Right hand side also we are taking tan pi by 2 minus z by 2. Some relation definitely we are getting. All these terms are in terms of tan. So what we have from here, we have tan x by 2 plus y by 2. So definitely break this. Tan a plus b, tan a is what? A is x by 2, b is y by 2. Break this, so we have tan x by 2 plus tan y by 2 upon 1 minus tan x by 2 into tan y by 2. Right? Right hand side we have what? Right hand side we have tan 90 minus theta. 90 minus z by 2 is what? Pi by 2 minus z by 2 minus 90 minus z by 2, that is cot theta. Cot z by 2. Right hand side is cot z by 2. So this is what? This is basically we are having this particular identity. And now how do we apply the informations, or how do we just prove this identity now? So simply one thing which you have to know, that simply definitely there is one way. You first cross multiply and then see what happens, isn't it? We first cross multiply this. We have what? We have tan x by 2. Tan x by 2 plus tan y by 2. Over here on the right hand side, after cross multiplication, we have cot z by 2. Cot z by 2 minus tan x by 2 into tan y by 2 into cot z by 2. Right? Tan x by 2 into tan y by 2 into cot z by 2. This is what you're getting, right? Okay. Now question is, how will you bring into this format, this product format? Any other thing, any other simplification? Definitely you have caught everything you need in terms of tan. So break this in terms of tan. Break this cot into tan. So we have tan x by 2. We have tan x by 2 plus tan y by 2 equals to cot z by 2 can be written as 1 upon tan z by 2 minus this particular cot z by 2 also I'll write this as tan z by 2, 1 upon tan z by 2. So numerator we have tan x by 2 into tan y by 2 divided by tan z by 2. Cot theta is 1 upon tan theta. Okay, clear with this? What we are getting? So denominator is now common tan z by 2, tan z by 2. We can write this as 1 minus tan x by 2 into tan y by 2 divided by tan z by 2. Denominator is common. So is the pattern coming? What is the pattern on the what we need to prove actually? We need to prove tan x by 2 into tan y by 2 plus tan x by 2 into tan z by 2 plus tan z by 2 into tan y by 2 is equals to 1. Definitely, simply cross multiply, you will get this thing. Simply cross multiply. What we are getting? Simply cross multiplying. After cross multiplication, cross multiply. Denominator is common, tan z by 2, tan z by 2. So tan x by 2 into tan z by 2 plus tan y by 2 into tan z by 2. Right hand side we have 1 minus tan x by 2 into tan y by 2. So simplify this. We have what? Tan x by 2 into tan y by 2. Take this thing on the left hand side plus tan y by 2 into tan z by 2 plus tan x by 2 into tan z by 2, which is equals to 1. And we have proved this. Chalo, last problem for today is from JEE Mains 2019. Achha, JEE Mains 2019. Okay. For any theta belongs to pi by 4 and pi by 2, open interval is given. Why this is given? To confuse you that you don't take the value of the end points, the end values, end regions, that is pi by 4 and pi by 2, right? Or they are just simply mentioning that don't take these end points pi by 4 and pi by 2. Take something in between, but definitely. So you have this expression 3 sine theta minus cos theta whole to the power 4 plus 6 sine theta plus 4 cos theta whole square plus 4 sine to the power 6 theta. What is this expression equals to? simplify this thing. That is what this question is saying. Simplify this expression. Simplify and say what is this expression saying. Okay. So normally what students did is after observing this thing that theta belongs to pi by 4 and pi by 2, the first thing which will come to your mind, that is basically sine theta minus cos theta whole to the power 4 is there, right? And first thing, theta belongs to open interval is there, mane pi by 4 is there, pi by 2 is there, that is still open interval. And this means what? This means definitely this lies in the first quadrant. This means the first quadrant only. Pi by 4 and pi by 2 is with the, like it's the first quadrant only. But the problem is, it is open interval. So what students did is they just simply expanded this thing. Obviously that is a bit time consuming, but still there can be certain chances of mistake, creating certain mistakes. In this case, you will have calculations definitely. Whole to the power 4 is there, whole square is there, and then you have certain terms. Now 3 into sine theta minus cos theta whole to the power 4 is there. Mane, what students did is they are creating a sine theta minus cos theta whole square, that whole square, and whole square ka whole square plus 6 sine theta plus cos theta whole square. Now what they did is sine theta minus cos theta whole square. So that's same as if we just break this sine theta minus cos theta whole square. So this becomes some terms. So 1 minus, it is basically 1 minus 2 sine theta cos theta. Once again whole square. Once again you are going to break that. That is also fine. You are going to simply simplify this expression. That is accepted. It may happen that it might consume your time in case if your calculation speed is not so fast. In case if you have a lot of practice and calculation speed is very nice, definitely you can simply just go by the general rule of just simplifying this thing, right? Or what you can do is, in this case you will see that this particular thing pi by 4 and pi by 2 will not work. The thing is, not work means basically even if you take the end values, then also this will not harm, because this thing is a trick actually. In fact, in this particular question, in these type of questions, what we do is either there is a specific trick to solve this question which will help you. The meaning is you have the first quadrant is there. We have pi by 4, pi by 2. You take the values of pi by 4, take pi by 4, take pi by 4 and take pi by 2. Okay, take pi by 4, take theta as pi by 4 and pi by 2. Put these, check the entire expression whether this is given some values, and see the options by putting the value of theta in each. Match with the options. That is also allowed. Or else you need to simplify this. What I'm going to do is, first I'm showing this simplification method. In the simplification method, you will see that we are not using this value of theta, pi by 4 and pi by 2. We are not using this information even. If you just see the simplification, you have the simplification of this. Let's simplify this first, then we'll go by this trig method, or what is there. Just simply we'll go by that. If you simplify this thing, 3 sine theta minus cos theta is there. So what we do in this case is we simplify this. So you need to be very fast in your calculations first of all, in case if you are simplifying this thing. 3 into sine theta minus cos theta whole square. Once again you are having whole square. So sine theta minus cos theta whole square, you have to calculate this mentally. What is sine theta minus cos theta whole square? Sine theta minus cos theta whole square means sine square theta minus plus cos square theta minus 2 sine theta into cos theta, isn't it? Sine square theta plus cos square theta will come, which will make this to be 1. Sine square theta plus cos square theta is 1. And you have minus 2 sine theta cos theta. So we have 1 minus 2 sine theta cos theta whole square, right? Plus 6 sine theta plus cos theta whole square. If you break this sine theta plus cos theta whole square, so sine square theta plus cos square theta plus 2 sine theta cos theta. Once again, sine square theta plus cos square theta will come, which is 1. So this is basically 1 plus 2 sine theta cos theta, right? And over here you have 4 sine to the power 6 theta. Okay. Also we have, so what we do is we now simplify this thing. Once again we simplify this whole square. So we have 3 into This is 1 minus 2 sine square, so 2 sine theta into cos theta. If you simplify this, so we have 1 minus 4 into sine theta cos theta, sine theta cos theta, plus 4 sine square theta cos square theta. Simply breaking this in whole square format, a minus b whole square. Okay. Plus we have this thing as 1 plus what we have 1 plus 2 sine theta into cos theta, right? There was 1 6, I missed out this 6 into this thing. Okay, 6 into 1 plus 2 sine theta into cos theta, plus 4 sine to the power 6 theta. Now what we do in this case? What should we do now? Simplification, basic simplification. So now certain things you have to do very fast because definitely time factor is a big problem in this case, because 3 into minus 4 sine theta cos theta, this thing 3 into minus 4 sine theta cos theta, and here also you have 6 into 2 sine theta cos theta, which will cancel out for 12 minus 12 sine theta cos theta and plus 12 cos sine theta into cos theta. This will cancel out. These terms will get cancelled out. You are left with 3 plus 4 sine square theta into cos square theta. Okay. Further, you can simplify this. So basically what we have is, you have 3 is there, 6 is there. So we have total 9. 9 is a constant. What else we have? Plus. Now regarding these terms of sine square theta and cos square theta, we have 3 into 4, that is 12 sine square theta cos square theta. 12 sine square theta cos square theta. Plus all these things we have simplified. Now we are left with this sine to the power 6 theta. Now we cannot simplify all these things now. Now we have to focus on the simplification of sine to the power 6 theta. Now sine to the power 6 theta, how will you simplify? How will you simplify sine to the power 6 theta? Understand very carefully. You have learned multiple angle, submultiple angle, right? So sine to the power 6 theta is there. How will you simplify this thing? Can we write this as, for your simplification, I'm writing the sine to the power 6 theta as sine cube theta, or let me write this as sine square theta whole to the power 3. Sine square theta whole to the power 3. Definitely we can write this sine square theta whole to the power 3. Why I am writing this? Because this sine square theta, you can further break this into 1 minus cos square theta, and here also you have sine square theta. We can break this into 1 minus cos square theta. Because why I am doing this thing? Because in this case, first we start omitting out the options, because in this thing you can see that there are 2 options. First I'll go with this option first. There are 2 options where there is only cos theta, only in terms of cos. Terms are there only in terms of cos. So it's better to break this into cos square, and then let's see what happens. 1 minus cos square theta is there into cos square theta. So this becomes 9 plus 12 sine square theta into, now not 12 sine square theta, 9 plus 12 into 1 minus cos square theta into cos square theta plus 4 into, break this into 1 minus cos square theta whole cube. Okay. Once again simplify this and then again multiply, try to, let's see what happens now. 9 plus, we have 9 plus 12, 12 into this thing 1 minus cos square theta into cos square theta. So we have 12 cos square theta, 12 cos square theta minus 12 to the power 12 cos to the power 4 theta. Right? Plus 4 into, now we have 1 minus cos square theta whole cube, a minus b whole cube formula. No other option. Break this a minus b whole cube formula. A minus b whole cube, that is basically 1 minus 3 cos squared theta plus 3 cos to the power 4 theta minus cos to the power 6 theta. A minus b whole cube formula. Okay. So what we have? Now simplify this thing. So we have 9 plus, so we have 9. Now see 12 cos square theta, right? 12 cos square theta, we have 4 into 3 cos square theta, this thing, right? That is basically 12 cos square theta. So cancel out. These terms are getting cancelled. 12 cos to the power 4 theta and we have 12 cos to the power 4 theta. These terms are getting cancelled. So you are left with 9 plus 4, this 4, 9 plus 4 and minus 4 cos to the power 6 theta. So 9 plus 4 is 13 minus 4 cos to the power 6 theta. B is the right answer. But this is more stressful to do so much of calculations. In the exam, you have so much of pressure in your mind and you will end up creating mistake. Right? In case if your calculation is very fine, then I have seen students just getting just afraid of this thing, say pi by 4 and pi by 2, giving this to be under open interval. Their students get confused. So what is the best thing? Best way to solve this thing is assume two values pi by 4 and pi by 2. Theta is pi by 4, pi by 2. There will be no problem at all. You take pi by 4 and pi by 2. Okay. This is a shortcut way of solving this. Take pi by 4, take pi by 2. No logic behind this. This is a shortcut, short trick I'm saying. You can take this. Pi by 4 and pi by 2. Because pi by 4, why I'm saying, because while simplifying this thing, I found that there is no use of this pi by 4 and pi by 2. Okay, so better is you take pi by 4, theta is pi by 4 and pi by 2. They have only mentioned open interval just to let you know that you cannot include these values pi by 4 and pi by 2. For instance, if I take pi by 4, theta is pi by 4, what happens then? Simply put theta to be pi by 4 and simply simplify this expression. 3 sin theta minus cos theta whole to the power 4, and all these expressions you are going to simplify. Okay, you will get some value. And similarly, you will take theta as pi by 4 and put in each of these options. Check that whether values are equal or not. I think there will be two values equal. If you put pi by 4, theta as pi by 4, two options will give you same value. Now to omit out between those options, what you are going to do is you are going to take the value of theta to be pi by 4, pi by 2 also you are going to check. Okay. But this thing, this particular thing is a trick actually to solve this question. There is no specific logic, but still this is the, in case if your calculation is fast, then you can go by this method. This is just calculation, just basic calculations, formulas, use of formulas, nothing else. Simply just simplify this. Maybe there is a more any other formula if you use, then this might be done in a more shorter way. But I think this thing we have done whatever it is. So this is a correct approach and correct answer also we are getting, which is 13 minus 4 cos to the power 6 theta.